For decades, software design relied on a reactive feedback loop. You provided an input, the machine processed it, and it delivered an output. We are now seeing a transition toward anticipatory systems, where the machine initiates action on a user's behalf before a prompt is given. This shift is powered by ambient technology and Internet of Things, or IoT devices. The Internet of Things is a network of physical objects embedded with sensors and software to connect and exchange data with other devices over the Internet. These systems continuously learn from our behavioral patterns in the background. We are moving from static tools that wait for instructions to dynamic environments that predict our intent. Humans suffer from significant decision fatigue, making an average of 20,000 decisions every day. Predictive user experience, or UX, attempts to solve this load. By automating mundane choices, these systems seek to free up our mental bandwidth. But this automation creates a hidden friction, the experience bubble. Algorithms optimize for past behaviors. This traps users in a deterministic loop of repeating events, where the system only offers what it has seen before. To move AI beyond this determinism, we must shift our design imperative. We should not merely automate chance, we must actively engineer sagacity. The ultimate UX challenge is architecting systems that preserve human agency within these predictive models. To solve this, we must ground our UX theory in the work of theoretical biologist Robert Rosen, who developed a formal framework for biological anticipation. Rosen's model consists of three components: object system S, predictive model M, and effectors E. The M block simulates future states of the system and environment. Using those forecasts, it triggers antecedent actions in the present through the effectors. This differs from standard reactive models, which can only respond after an environmental change has already moved through the causal chain. True systemic anticipation requires an internal model capable of pulling the future into the present to dictate proactive control. Mapping Rosen's math onto modern AI architecture reveals exactly where current consumer-facing systems fail. In this translation, Object System S becomes the user and their behavioral data. Predictive Model M becomes the machine learning algorithm, which uses statistical techniques to learn from data without explicit programming. Finally, effectors E are the automated UX actions executed on screen. Here is the architectural friction point. Most algorithms optimize for statistical probability based on historical data, but they lack a mechanism to interpret the actual intent behind those actions. This creates the experience bubble. The algorithm optimizes for returning past events, lacking a way to understand why a user's needs change. The automated interface traps the user in an isolated loop, disconnected from novel environmental inputs. When the predictive model lacks the context of human intent, the system degrades into algorithmic determinism, stripping the user of transparency and control. Industry attempts to fix this bubble usually rely on collaborative filtering recommender systems. This method makes automatic predictions about a user's interests by collecting preferences from many similar users. However, collaborative filtering merely automates chance encounters within pre-calculated parameters. It offers the illusion of novelty within a mathematically confined boundary. In the history of science, serendipity is more than a random encounter. It requires human preparation to recognize the value of what has been found. This recognition relies on sagacity, the specific domain expertise and mental preparation needed to extract meaning from unexpected data. This presents a systemic contradiction. Pure serendipity cannot be mathematically generated. If it is programmed, it ceases to be serendipitous. An AI system's role is not to force connections for the user, but to prepare the user's mind to make the connection themselves. A serendipity hunter model bridges entirely disjointed datasets, exposing users to concepts they would never naturally encounter in their own bubble. Superior UX design engineers sagacity by exposing users to cross-domain models, providing the raw materials for discovery. We must move away from generalized AI that seeks to entirely replace human decision-making. Instead, we should architect extended intelligence, where technology serves strictly as an extension of human capacity. This requires algorithms to transition from rigid binary outputs to responsive, conversational models. To achieve this, designers must open the algorithmic black box, providing transparency so users can teach the system the intent behind their preferences. Personality must be designed into these interfaces to foster human-like relational dynamics, moving beyond simple data extraction. Trust in an anticipatory system is only possible when users retain the agency to audit, correct, and converse with the algorithm's assumptions. Integrating these mandates will physically alter the system architecture. By creating a transparency and control mechanism, we provide a direct feedback pathway between the user and the algorithm. This direct control fosters domain expertise, acting as a sagacity multiplier for the user. The goal of anticipatory design is to use predictive models to clear away the 20,000 mundane decisions we face daily. Reclaiming this cognitive bandwidth provides the necessary space for high-level, cross-domain discovery. The future of UX rests on an architecture of anticipation that secures human agency within predictive models.